So this is a homework for the subject of digital design. In this homework, we use a FPGA to program it and do some logical operations in them. So first of all, I'm going to explain what is a FPGA. And FPGA, it's a field programmable gate array, and it's a type of integrated circuit that can be programmed or reprogrammed after manufacturing. It consists of an array of programmable logic blocks, and these are interconnected and those can be configured to perform various digital functions. In this subject, we are seeing the logical gates. We have 6 of them, and a logical gate is a device that acts as a building block for digital circuits. They perform basic logical functions and operations that are fundamental to digital circuits. And here in the image, we have the 6 truth tables that each one of them performs as outputs. So the code is to, as I mentioned before, to program an FPGA board, and it is used the VHDL language. This code is in VHDL language. So first of all, we have the libraries that it's the E one, and this is in order to use the other commands that I used for the code. So first of all, we have this code is based in this diagram, and as we can see, it has 4 switches that in this code are defined as inputs. So each input is defined as a letter. So we have A, B, C, and D that are going to be like in this diagram 1, 2, 3, or 4. Then is defined the architecture of the code. Here I added some signals that I name it as aux1 and aux2, and these are going to be like the outputs of each gate that are not the inputs but are not also the outputs, so are going to be like just in the board. So after I assigned the signals, it begins the like what is going to be doing the board. And as we can see here, the aux1 is just an operation of a NOR gate between the A and B input that are going to be like 1 and switch 1 and switch 2. Then aux2, it's a logical operation of NOR. It's a NOR operation between C and D input, that it's the third and fourth switch. And the output that is named as F is just an AND operation that it's like a multiplication of the previous outputs that I name it as aux1 and aux2. And here we can see the diagram. This second code follows the same structure, just that it follows this diagram. And as we can see here, is similar to the previous one, just that the third and fourth OR gate it's negated. So in this code, I also used 2 signals that I named also as aux1 and aux2. And the difference between this code and the previous one is that I used a NOR operation instead of an OR between the C and D input that are the third and fourth switch. In this third code, I follow this diagram, and as we can see here, it has three switches. That means that we're going to have just three letters that are in the code, as we can see here, A, B, and C. The F is the output that is also defined in the code. So in this, I also use two signals, and auxiliary one, it's just an operation between the A and B input, that is the first switch and the second switch. The auxiliary 2 is also an AND operation between B and C input, and those auxiliaries in outputs are uh, then used to make a NOR operation, and that is going to be the output, as we can see here in the diagram. In this fourth code and final code, I follow this diagram. As we can see here, it also has just three switches. And also what I did is to follow the same structure, and it only has A, B, and C, and F is the, as we remember, is the output. So in this code, I needed to of three signals, and I name it as aux1, aux2, and aux3. So the first thing, as we can see in this diagram, is to negate the first switch, the first input. So A is negated here, and I used a NOT operation to accomplish that. Then the aux1, that is a negation of the A input, is used with B as an AND operation, as a multiplication. Then aux3 is just a NOR operation between B and C input. And then the output is just an addition or an OR operation of the aux2 and aux3. The software that we use to program the FPGAs is Quartus. I use the 18.0 edition. So in order to upload the code, I needed to use this program, and in order to accomplish that, I had to put assign the pins, because the board has many switches, and each one of them are named differently. So I have to check the datasheet and see which one of the pin I uh, I could use, and what were the name of them, and assign it to, and I had to assign it to in the code. And as we can see here, the A is the pin AB28, that is switch 1, switch 0. And as the output, I use the first LED that is in the board, that is named as pin G19.